Our final lesson in Chapter 9 is 9.5, hyperbolas. A hyperbola is a unique type of conic section recognizable in your equation because it uses subtraction. So between the x squared and y squared terms, we have a subtraction sign. Notice you either can have x squared or y squared first. So the unique thing here is that the order does matter. Before, when we had addition, it didn't matter if x squared or y squared was first, but now it does. So order matters. A hyperbola is defined as two curves that approach an asymptote. And an asymptote is a very unique word. It's fun to spell, but it's actually a line that a graph approaches but never crosses. So it's kind of like a boundary line. And you'll notice when we sketch the graph for a hyperbola that we have not only one asymptote line, but there are in fact two. A hyperbola is similar in setup to an ellipse because we have one on that right-hand side. So in standard form, when the center is at 0, 0, you're either going to have a horizontal hyperbola or a vertical hyperbola. And it's designated by whatever letter is first. If x squared is first, then your shape is going to be horizontal. So that will be important to note. Also notice, so you have your center, and now we only have two vertices. We go to a vertice on the left and a vertice on the right. And then we have those two asymptote lines drawn in, but we don't have minor vertices this time. So that makes this unique. The x-axis is known as the major axis. And the curve in blue is actually the hyperbola shape itself. So the hyperbola opens to the left and to the right. And the unique thing for hyperbolas also is that a squared isn't necessarily greater than b squared, but it is always first. And you'll know that because that's the direction that your hyperbola will open. So we don't necessarily need the b squared for ordered pairs, but we use the b squared to create our asymptote lines. All right, so for a vertical, if you have a vertical ellipse, you'll know it because y squared is first this time. So if y squared is first, then it's going to be vertical. So now notice the 2 points that we graph are on the y-axis. That means the y-axis is now the major axis. And you'll use that b squared number eventually to help create those red dashed asymptote lines, but then the hyperbola itself opens up and opens down. And I suppose it's important to note, we'll draw a little arrow to these red lines right here. Those are the asymptote lines. A-S-Y-M-P-T-O-T-E-S. So that's an asymptote line. And so is this one down here. All right, let's take a look at some actual hyperbola equations. When graphing on a hyperbola, our key features are a little bit different from circles and ellipses. We'll determine where our center is located, but we're not actually going to use that to connect to anything. And that's kind of what we've done before. Now we find our center the exact same way we did for circles and ellipses. If you look at your quadratic terms and nothing's being added or subtracted in a parenthesis with them, the center will default to 0, 0. But we can also translate them, and we'll do that on the next page. Then we're going to plot our major vertices, and we're going to use a squared every time to do that. And remember, a squared is always the first number. Whether or not it's bigger than the b squared doesn't matter this time. Then we have to sketch those dashed asymptote lines by creating a rectangle. And that's when we'll always use that second number. So the second number doesn't actually create vertices, but it'll help us create those asymptote lines. Once we have those lines drawn in, we do the sketch for the hyperbola. So please make sure you have these steps written out on your paper, and then we'll move on to the two examples on the right. Graph each hyperbola. State the center and vertices. So we're going to actually just do all of the key features here. I don't know why I don't just have key features written out. I should. So we're just going to sketch all the key features, and then we'll draw in those asymptotes as well. We have x squared over 9 minus y squared over 16 is equal to 1. Because x squared is first, this is going to be horizontal. And that means that the hyperbola will open up to the right and to the left. To find our center, we look at the x squared and the y squared. Since nothing's being added or subtracted, that will be right at 0, 0. So go ahead and plot that point. To find our major vertices, and there are only vertices, believe it or not, to find those major vertices, if a squared equals 9, then we're actually going to go the square root of 9. So we'll go 3 to the right and 3 to the left from the center. If we go 3 to the right, we'll be at positive 3, 0. And if we go 3 to the left from the center, we'll be at negative 3, 0. Let's go ahead and plot those points as well. 3 to the right and 3 to the left. To sketch our asymptote lines, we actually create a rectangle. And we use the b squared to help us. So if b squared is 16, I'm one step ahead of myself, then b would actually equal 4. So what we're going to do from the center is we're going to go up 4 and down 4, kind of like we did with minor vertices, but then we're just going to put a star there, or a little X on that location maybe. So if I count up to 4, I'm not going to do a whole star. I'm just going to make a little X right there. And then I'll do the same thing at the bottom. So kind of like X marks the spot for those. So here's how this rectangle thing works. We're going to go from those 2 points and kind of just create a rectangle to the left and then down through our major vertice on the left, and then go back to the bottom over here to the right and go up through that major vertice. And just like that, that's how you create your rectangle. So we want to make sure that it's kind of got those right angles at the top right, top left, bottom right, bottom left. And now what we do, we actually go through the center, and I'm just going to draw kind of up through the corner all the way to the top of my graph, and then I'll connect to the other side. So this is the only reason the only part for the center that we need to, or the only time we actually need to use the center. So then I'm going to do the same thing in the other direction. I'm going to count down here and go through like so, and then up through here at the top. And that is how we draw in those asymptote lines on our graph. We can actually create an equation for that, but that's something that you'll look at next year in Honors Functions and Trig. Now, for step 4, to actually sketch the graph, go back to those major vertices and make sure they're kind of darkened in so that you know exactly where they are. Now, the asymptotes, remember, the graph will approach them but never cross over them. But it does go through each of the vertices. So I'm just going to kind of make that vertice and kind of curve my shape up to the top right, and then do the same thing down here towards the bottom. Now, you never actually want to cross over that asymptote line, and you don't want to curve your shape back in. So we want to have our graph extend in both directions. I'll do the same now on the other side, up here to the top. So it's really kind of wide. Oops, I kind of missed that vertice too, didn't I? Let's make sure to throw that in there a little bit. Go through here and then down on that bottom left-hand side as well. So the actual green curve is the shape for the hyperbola. And that's all you do. Let's try another hyperbola centered at 0, 0. Y squared over 25 minus x squared over 10 is equal to 1. Again, recognizing that the variable which is written first will identify the type of hyperbola we have. Since y squared is first, this is definitely going to be vertical, which means the hyperbola will open up and down. To get our center again, always checking for x squared and y squared. Is anything written in that would make this kind of translate? And in this case, no. But here's something that's important to note. Remember that x always has to go first for the center. In this case, it's not that big of a deal, but when we translate centers, we have to identify our ordered pair in the right order. So that's just something to think about now before we go to the next page. All right, to get those major vertices, we use I squared. We use a squared. A squared is 25. So if a squared equals 25, and we take the square root of each side, then a will equal 5. Which means we're going to count up 5 and down 5 from our center to get those major vertices. That would be 0, positive 5, and 0, negative 5. All right, down below on our graph, let's plot our center Let's plot +5 up at the top and -5 down at the bottom. Those are really the only points that we plot. Now to create our asymptote lines. There we go, asymptotes. Remember, now we're going to count to the right and to the left. So b squared this time equals 10. Not a perfect square. But the nice thing about doing this is that we're just going to approximate because we're not creating ordered pairs. The square root of 10 is about 3.2. This makes this a little bit trickier to graph, but we'll try our best to make it work. I'm just going to count 3.2 to the right, just put a little X kind of right there, and 3.2 to the left, and just put a little X marks the spot right there. Remember, they're not ordered pairs, so try your best not to use those points, but we are going to use them to create our rectangle. I'm going to start at the top again, so I'm going to start at that vertice at 5 and go over to the left and just kind of try to sketch that as best I can through that line. I know it's a little tricky, so we'll just try our best to make that work. And then do the same thing on the other side, a little bit past 3 and go up through. That X marks the spot, and then connect it like so. There's your rectangle, just like that. Again, from the center, please connect through the corner of that rectangle and go all the way up. Draw your line or your arrow and then go all the way to the bottom. And do the same thing on the other side. Like so. Try your best to make those as straight or linear as possible. All right, last but not least, let's sketch our hyperbola. Remember, we're going to go through 5 at the top and -5 at the bottom. You want that hyperbola not to touch the center, but just those vertices, and curve over to the right side of your asymptote and then over here on that left side, and then the same thing on the bottom. Try not to get too close to that edge. So maybe just kind of move that over just a little. And that's graphing hyperbolas with centers at 0, 0. You'll know when looking at an equation that the center is translated if x and or y has a parenthesis moving that center from 0, 0 either left or right or up or down. In this case, we have y plus 2 squared over 1 minus x plus 3 squared over 9 equals 1. Again, decide the direction for your hyperbola, and it's whatever is written first. Since the y variable is first, we know that this is going to be vertical again. So that means that the shape of the hyperbola will open up and open down. But now this is where I was telling you about be careful for the center. We know the center is going to be translated. We've done this with circles and we've done this with ellipses, so that part's not tricky. What makes this one tricky is the order in which you write the ordered pair. If it's y plus 2, it's going to move -2, but that's going to be down 2, so that's the y coordinate. And if it's x plus 3, that means we're going to move left 3 for the x coordinate. So again, just put a big star right there, x first, and then y has to be written second for the center. So let's go ahead and plot that right now. -3 down -2. All right, to get those major vertices, now everything else should be pretty straightforward. To get those major vertices, and again, these are the only vertices that we plot. If a squared equals 1, and we take the square root, then a just will equal 1. Now remember, how we do this, this has to go up and down from the center. So we're going to do -2 plus 1, and then we'll do -2 minus 1. So that's going up and going down from the y part of the center. If we go up 1, we're going to be at -3, comma, -1. And if we count down 1, we'll be at -3, -3. So let's plot those points to see if they seem valid. If we go up 1, there's -3, -1. Kind of darken that in there, and then go down 1, -3, -3. And there you go. Those are your major vertices. Now to create those asymptote lines, we use that b squared. B squared equals 9. So if we take the square root, we're going to go 3 to the left and 3 to the right from the center, and that's where we'll be able to draw in that rectangle. If we count 3 to the right on the graph, we're right on that y-axis. So I'm just going to put a little x there. And if I count 3 to the left, I'm over here at -6, -2. Now this rectangle is going to be pretty tiny, so I'm going to go over here to the graph and kind of zoom it out a little bit to make it easier to draw. Remember, we want our rectangle to go through the major vertices, like so, just kind of drawing that dashed line all the way around, like so. So if I zoom back out so I can see my entire graph, remember when we connect these, we're going to go through the center, all the way up to the right. So this is going to be a big line, and then down through the left. Oh, that was really off, wasn't it? Wow, that's really off. Sorry. All right, let's try it. So hopefully the second way will go a little bit better. Go through this way like so. There we go. All right. And make sure they all have arrows because they are actual lines. All right, so let's go ahead and do our last step, sketch that hyperbola using those major vertices. This is going to be a super wide looking shape. If we sketch from the vertice over to that right-hand side, the left-hand side, and then all the way over to the right-hand side, it's going to go all the way up like so. Try to get it to be curved as best you can, and then down here to the bottom right. All right, I'm gonna have you guys try the last one. See if you can find some of those key features, and then we'll go through it together. So actually pause the video, try to determine the center and the major vertices, see if you can connect or create the asymptote by drawing in that rectangle. When you think you have it, press play, and we'll see how you did. All right, let's see how you did. I found that X was first, making this a horizontal looking hyperbola when we're done. The center translates 4 to the right and down 2, and X is first in this one, so the order pair should go right in that order. Now for the major vertices, a squared is 9. Remember, it's always first, even if it's not bigger. So that means we're going to go 3 to the right and 3 to the left from the center. So what I did was I added 3 and I subtracted 3. And that gave me 7, -2, and 1, -2. And then for those asymptote lines, I used the b squared and I went up 4 and down 4, created the rectangle, and then drew in the diagonals from corner to corner. And that creates the shape for the asymptote lines. Now the horizontal hyperbola has to open to the right and to the left. So using those major vertices that we plotted in step 2, curve it kind of up towards that top asymptote and down towards the bottom using arrows. And then do the same thing on the other side, kind of down towards the bottom and up towards the top. And that's sketching the translations for a hyperbola. We'll stop the video here and then we'll complete the square to write them in standard form in class.